Yes. My laptop is screaming. Oh boy.
大丈夫大丈夫。僕今スクリプト書き終わったから。LT はどうすんだろう。なんとかなるでしょ。
So I made some errors in my cut, so I will try to fix them still.
Devan までは時間あるでしょ。出番までは時間あるでしょ。
Ah, large debt.
まあ
Me too. Me too. Right, too busy.
今日ご飯も食べれなかったよ。準備で忙しかったから。今マグロちゃん食べてる。大丈夫。僕も今から練習するってしてるから。まだ10分あるもん。
Yeah, was some other review link to the video soon. Not sure if I will stay up until my time slot though. 5 a.m. I didn't sleep. No sleep.
Hello, can you hear me? Hello. Let me check it. Fine. Okay, thank you. So, hi everyone, for tuning in. Welcome to Talk Together Chef 2, or casual online lighting talk event for all things. 日本語で言うの忘れたね。こんにちは。ご清聴ありがとうございます。本日はね、技術系オンライン LT イベント Talk Together の第2回目見に来てくださってありがとうございます。このイベントは誰でも気軽に参加できるカジュアルな技術系 LT イベントとなっております。ちょっとオフラインじゃなくてね、限定にはなるんです。So, this event is open to anyone who wants to share something technical they're passionate about. 技術というゆるいテーマのもと、登壇者の皆様に好きなこと、だいたい5から20分ぐらいで自由に話していただくイベントとなっております。Speakers will be given prior to 20 minutes talks on topics they love, all under the broad theme of technology, like Go, C#, Python, Unreal, C++, something で、本日もですね、日本語と英語どちらの発表もありますので、内容もまたいろいろとジャンルが揃ってなっています。また合間に休憩をちょっと挟んでゆったり見ていくと嬉しい。Today, we'll have presentations in both Japanese and English, covering Unity and C++ and server-side technology. We also included some short breaks between sessions, so feel free to relax and enjoy. では、12時5分から最初のトルムさんによるユニティゲーム開発の ABC の発表が行われますので、今しばらくお待ちください。Our first talk will begin in a few minutes, presented by Tron, is the ABCs of Unity game development. So please stay tuned.
見えますか？
So, yeah, Troom's PC is kinda in trouble, so yeah, I know, I know. So maybe we can. あ、ちょっと待ってね。
今いけます。
今いける？
見えますか？
ね、見える見える見える。こっち。よし。
では、始めます。
はい。じゃあ、お願いします。
皆さん、こんにちは。ユニティゲーム開発の ABC について発表させていただきます。まずは自己紹介です。トルムと申します。ユニティ C# ゲーム開発を独学しています。私は韓国人で日本語を勉強中なので、ところどころ拙い部分があるかもしれませんが、ご了承ください。この発表について質問がありましたら、X や Discord で DM をいただければ誠心誠意お答えします。最初のチップは、常に Git を使うことです。Git はファイルの変更履歴を管理して問題があったときに元に戻せるツールです。そして Git を使うだけではなく、どのタイミングでコミットするかという習慣もとても重要です。小さな変更ごとにコミットしておくと、後で原因を調べるときやロールバックするときにすぐ対応できます。最初から Git を使う習慣をつけておくこともお勧めします。次は B、アセットストアを活用することです。アセットストアには Unity で使える高品質な有料無料アセットがたくさんあります。これらを活用すれば、モデルや素材を自分で一から作らなくても、 すぐにシーンを組んで試したり、プログラミングの学習に集中したりできます。学習段階では制作よりもユニティの使い方を覚えることが大切だ。なので、アセットストアを積極的に活用することで効率よくスキルを身につけられます。次は C、読みやすいコードを書くことです。コードを書いているときは動けばそれでいいと思いがちです。でも数日後に自分で読んでも何をしているのかわからなくなることがよくあります。読みやすいコードを書くためには書いた後に必ず読み返してみること、変数名や関数名が役割を正確に表しているか確認すること、不要な処理がないかを整理することなどが大切です。一つの関数には一つの役割だけを持たせること、ディバッグや修正が簡単です。そしてゲーム開発を仕事としてするなら、チームで協力する中で他の人がコードを理解できることもとても重要です。次は D、フォルダ構成を整理することです。フォルダ構成を整理しておくことは、Unity での学習や開発を進める上でとても大切です。プロジェクトが大きくなると、どこに何かいるかわからなくなって作業効率が落ちたり、同じファイルを2度作ってしまうこともあります。最低限、シーンズ、スクリプト、プリファブス、マテリアルズなど、よく使うフォルダは最初に作っておくと便利です。また、アセットストアからインポートしたアセットはサードパーティーフォルダにまとめておくと管理が楽になります。最後は E、ユニティドクスを習慣にすることです。ユニティで新しい API やまた慣れてないクラス、メソード、プロパティ、イベントなどを使うときは、必ず公式ドクスでその API リファレンスを確認する習慣をつけることが大切です。公式ドキュメントには最新で正確な情報が載っていて、使い方や注意点を事前に知ることで、無駄なエラーやバグも減らせます。学習段階からこの習慣を身につけておくと、自分で問題を調べて解決する力も自然と鍛えられます。以上、ユニティゲーム開発の ABC として次の5つのチップを紹介しました。常に Git を使うこと、アセットストアを活用すること、読みやすいコードを書くこと、フォルダ構成を整理すること、そして Unity Docs を習慣にすることでした。これらを意識することで余計な試行錯誤にかかる時間を減らせると思います。今日の内容が少しでも参考になれば幸いです。ご清聴ありがとうございました。
Thank you. Next, we will talk about project started with the web API development using Go persuade while regularity はモプさんに Go を用いて API 開発の紹介となる。ちょっと準備できるまで少々待ってください。
あ、
お、お
おはようございます。
ざいます。いけますか？
はい、いけます。
です。じゃあ、お願いします。
はい、では、コネクト Go を利用した Web 開発、を発表したいと思います。あ、えーっと、はい、ハムオッピーと言います。はい、よろしくお願いします。で、本題なんですけど、API を作るのってなんかめんどくさくないですかっていうところです。なんかプロトコルどうしようとか、データ形式はどうしよう。JSON 使ったり、XML 使ったりとかいろいろあるんですけど、なんかその辺を考えたりとか、じゃあそれをどうサーバーで実装しようかとか、クライアントを、API ごとに作ったりとか、みたいなのめんどくさいなと思うことがあります。はい。でそこで ConnectGo っていうのを利用します。ConnectGo っていうのは、gRPC 互換の HTTP の API を作成するためのライブラリーです。プロトコルバッファーの定義ファイルからコードを生成してくれます。で、また、gRPC や gRPC Web、Connect の独自プロトコルの、3つの、接続の方法に対応しています。で、Connect の、独自プロトコルは HTTP1.1 でも動作するので、古い、Web サーバーの環境とかでも動かしたり、できたりとか、あとその、プロトコルバッファーの形式じゃなくて、JSON を使った通信もできるので、えっと、なんか、プロトコルバッファーを使えないようなクライアントから接続したいみたいな、実行したいみたいな、ユースケースなんかでも使えたりします。はい。で、プロトコルバッファーの定義ファイルからコードを生成っていうのは、例えばこういう、定義ファイルが、あったとします。プログサービスっていうサービスがあって、RPC っていうのがリモートプロシージャーコールで、一つの API になります。なので、これの場合だと、ポストっていう、記事を投稿する、API があるサービスがあって、記事を投稿するには、タイトルとコンテントがある、オブジェクトを送って、作ったら ID が返ってくるみたいな API を考えてみます。これを、コード生成すると、Go ではこういう、えっと、ポス構造体が、生成されます。ここに書いた、タイトルとコンテントのストリングの、フィールドがこっちにもあるのがわかります。で、次にサービスの、定義は、インターフェースが生成されます。そのままの、ポストの、関数があって、ポストリクエストのリクエストとレスポンスがあるという感じの、関数が、インターフェースで定義されているので、これを満たす実装をするという形になります。で、なので、さっきまでのは、自動で生成されたもので、あとはこういう感じの、実際の実装を、自分で書いていくっていう感じになります。で、このあたりは、インターフェースの定義の通りに、書いて、あとはこの中身の実装を自分で書いていく感じになります。で、今回の場合は、適当に create post っていう、別の関数を読んでるんですけど、構造体を自動生成してるんで、このリクエストにはタイトルとコンテントが入っているっていう感じになります。はい。で、いいところとしては、実際に、実装するときに HTTP とか gRPC といったプロトコル周りとか、データのシリアライズ、デシリアライズっていうところを気にしなくていいところがあります。でまた、型が決まっているので、コーディングが、しやすくなります。はい。で、クライアントも実は生成されて、こんな感じの実装が出てきます。なので、システム間の通信、をするときに、クライアントも生成されてるんで、特にこう、 新しい自分でクライアントを作らなくても、Go のシステム間だったら、そのまま、通信ができるようになります。はい。で、また、ブラウザ用のクライアント実装も生成できます。これは、Connect Web っていうものを使うと、TypeScript のクライアントを生成できます。生成したものは、こんな感じの、ブログ PB っていうファイルで、生成されるので、実際にはこういう、クライアントを作って、クライアントのポスト関数を呼ぶと、先ほどの、RPC が呼び出せるというふうになっています。はい。で、生成に関してなんですけど、プロト C というツールを使って、プロトコルバッファーの定義ファイルを読み込んで、でそこから、プロト C ジェンホネララっていう、プラグインを利用して、必要なファイルを生成していきます。で、今回、紹介した、内容だと、プロト C ジェン Go というもので、メッセージの定義から構造体を、生成します。プロト C ジェン Connect Go は、サービス RPC の定義をインターフェースで、生成したり、クライアントの実装を生成したりします。で、プロト C ジェン ES っていうのを使うと、ブラウザで使える TypeScript のクライアントが生成されます。で、生成されたファイルの内容なんですけど、この緑色の枠のところが生成されたものになります。ブログ PBTS というものは、TypeScript のクライアントが実装されているので、自分で実装しているウェブサイトからそれを使うだけで、API を叩くことができます。で、ブログ Connect Go というところは、Connect Go の実装が生成されていて、HTTP のハンドラーとか、先ほどのサービスのインターフェースの定義が、生成されます。で、自分で実装している blog.go という、自分で実装するファイルの中では、ブログサービスハンドラーのインターフェースを満たす実装を、するという形になります。また、ブラウザから、Connect Go のハンドラーの間は JSON でやり取りして、その JSON の内容を、デシリアライズして、構造体に当てはめて、その構造体で、実装できるようになります。で、まとめです。Connect Go を利用すると、クライアントサーバーの実装を生成することができます。生成された型を利用しているので、シリアライズ、デシリアライズを気にしなくてよくなります。また、ブラウザから、接続したい場合は、Connect Web を利用することで、クライアントを生成することができます。で、生成には ProtoCgen Honera という、プラグインを利用して各種実装を生成しています。ProtoCgen Go は構造体を生成して、ProtoCgen Connect Go は Connect のクライアントサーバーの実装を生成しています。ProtoCgen ES はブラウザで利用できるクライアントの実装を生成します。はい。以上で、発表は終わりです。ご清聴ありがとうございました。
ありがとうございます。いいじゃん。うん。で、もういないんだよな。あ、来た。ゆめさん。はい、準備の方お願いします。
はい。ちょっと待ってください。
はい、お願いします。So, talk by document titled the unique. Please wait.
はいはい。
はい
所長お待ちしよう。
はいはい。
と、スライドショー。設定を、ウィンドウ表示。よいしょ。 はいはい。
うん。
あ、なんかタイトルがあれだけど、はい。で
はい。
は、よろしくお願いします。
お願いしま
はい。
す。
はい。ユニコードについてお話ししようと思います。はい。私はてきめんです。はい。まあ、SNS こちらです。で、PHP のコミッターなどをやっています。はい。で、コンピューターで、文字を表すっていうことの基本、についてお話しすると、コンピューターは数値しか扱えないので、そこでとある数値を A などと紐付けるというふうな感じで、一つ一つ文字を紐付けていくことで、コンピューターで文字を扱うっていうことができるようにしていくというふうなことをやっていきました。それが文字コードというものですね。で、文字コードに照らし合わせて文字を表示してくれるというのがフォントになります。はい。で、問題だったことが、文字コードっていうのは、昔は各国各地域で作られていました。日本などでは、一つの文字コードでは済まされず、あの、複数の文字コードを作ったりしました。はい。その結果、読み手と書き手とで文字コードが一致せず、文字が化けてしまうということが発生してしまいました。この文字が化けるっていうのは、なんかバイナリーとか、そういうふうな文字になってしまうっていうことで、そういう、ことになって、ちょっと困るよねっていう話になって、あの、読み手と書き手とで、その文字コードが一致しなくて、それであの、文字化けという風な形になってしまいました。これを文字化けと呼んでいて、で、そのまま、海外でも文字化けという風に、呼ぶようになったということですね。はい。日本が特に文字化けに悩まされていたので、日本語そのまんま文字化けといった形になったということです。はい。で、そこで出てきたのがユニコードですね。はい。ざっくり言ってしまうと、ユニコードはいいぞということになります。で、文字化けから解放してくれたとっていうふうになります。はい。で、ユニコードを使っとけば、例えば UTF-8 とか UTF-16 とか UTF-32、UTF-32 とかそういったものを使っとけば、いいということになるので、あの、たくさん、いろいろな地域、国を一つにまとめてくれるということで、かなり良くなってきたということになります。これかなり省略してるんですけれど、しかもですね、絵文字も使えるようになったということになっています。絵文字ですね。で、これは絵文字っていうのはもともと、日本の、携帯電話、今ではもうガラケーとか、フィーチャーフォンなんていう風な言い方をしますが、2000年当時で、2000年だったかな、2000年ぐらいのすごい、すごい昔の時に、メールとかで、ウェブサイトとかで、あの、文字を使えるように、絵を使えるようにしようということで、絵文字っていうのを使えるようにしたということになります。はい。で、そのユニコードって何っていう風な話をしようという風な話なんですけど、世界中のすべての文字を収録しようというものになっています。で、ISO、IEC10、10646という、工業規格があって、ユニコードと等しくなるようになっています。はい。で、その、えっと、地域、その ISO、IEC1064 に基づいて、各地域で、各国、各地域で、その工業規格っていうものが、あるようになっていて、対応するようになっていて、それが JIS-X0221、日本だと、えっと、工業規格になっています。それが対になっているという形ですね。はい。で、ユニコードのバージョンに伴って収録されていく文字が増えています。で、これは様々な国、地域っていうか、今でもまだコンピューターの文字にできていない文字とかを収録しようというふうな、動きがあって、で、それで、文字を収録するっていうふうなことが増えて、あって、例えばユニコード、現在ではユニコードのバージョン16なんですけど、それが17になってくると、アラビア文字が何たらとか、何たらとか、そういうふうな感じで文字が増えていくっていうふうな形になっています。なお、あの、ユニコードの文字はですね、一応100万文字くらいは収録できていて、今のところ10万文字くらい の収録になっていて、一応、全世界の文字を収録しきることができるんじゃないかっていうふうに言われています。はい。ここだけ見ると、ユニコードって文字化けを開放してくれて、すべての地域を収録しようとしていて、っていう風な形になっていくので便利だろうなっていうふうに思うんですが、漢字ですね。はい。漢字、この文字、えっと、えっと、こ例えば、こういう、文字をひらがなと言って、この文字を、漢字、複雑な形しているこの漢字のことを漢字っていうんです。日本語では漢字と言います。で、これは中国が発祥で、中国語では漢字と発音します。で、なんで中国語の話をしたのかっていうと、ユニコードでは、中国語がベースになっていて、中国語でユニハンというふうなテキストファイルがあって、それがデータベースになっているということで、漢字というふうになっています。で、この文字っていうのは、表意文字、イデオグラフィックキャラクターに属します。これは、どういう意味があるかっていうと、文字に意味があるということになります。で、英語とか、そういった、発音に、文字を表すことを表音文字、フォノグラムキャラクターっていうふうに言います。文字が音を表すことを指します。で、例えば、ひらがなとかもそうなんですよね。はい。それも表音文字になるという形です。はい。では次、CJK。漢字が中国が発祥で、東アジアに伝わったことで、様々な漢字を許容しています。ただし、その国によって漢字は字形が違ったりします。ユニコードに統一することによって、これらの漢字も統合されるということになりました。これはですね、よく、X とかでは、勝手にアメリカ人が決めたとかいうふうに言われるんですけど、これはちゃんとCJK、チャイナ、コリア、ジャパン、チャイナ、ジャパン、コリアのその人たちが集まって、結局、一つにまとめた方がいいよねっていうふうなことを話し合って決めたということになります。はい。で、ユニコードを統一することによって、これらの漢字も統合されることになったということになります。はい。ということで、これらの国々のアルファベットの頭文字から CJK と呼ばれます。ベトナム語も漢字を使っていることがあり、その時は CJKV と呼ばれます。ただし、ベトナム語って現在では、表文字を使っていて、それを使っているので、ほぼそんなに使わないっていうようなことはあるんですけどね。はい。ということで、ちょっとサンプルを見てみましょう。はい。これ、化けるという字なんですけど、これが U プラス5316なんですね。ところが、フォントによって、文字の違いが発生しています。はい。で、日本語だと、ここの部分が飛び出ていないっていうのが特徴になります。はい。で、さっき、CJK で、統一するっていう風な話をしましたけど、統一しちゃったがゆえに、ここの文字が飛び出ていると飛び出てないっていうのが、統一されちゃったんですね。で、それをフォントで切り替えるっていう風な形にするっていうのがこういう仕組みになっています。はい、次。U プラス8005ですね。で、これはですね、韓国語のフォントになると、この点がついているということになっています。これが韓国語の特徴になります。はい。で、っていう風な形で、実は同じコードポイントを指しているんだけど、フォントによって収録されている文字が違うよと、文字がっていう風な形になっています。はい、次。10プラス 8A4。これはですね、中国語も日本語も韓国語も全て違います。はい。同じコードポイントなのに全て違うということになっています。はい。こういう風にですね、フォントによって文字の形が違うっていう風なことがあったりするので、お願いしたいことがあるということになっています。で、ユニコードでは CJKV を統一しているため、字形がそれぞれ違っていることがあります。で、この字形の違いっていうのは、なんかちょっと違和感があるなっていう風な感じで、現地の人からはちょっとあれ変だぞっていう風になったりします。で、これを日本では中華フォント問題、つまり中国語のフォントにデフォルトを合わせられちゃうので、そういう風な形で言われたりとかしてますね。だからフォントをですね、選んでもらえると嬉しいなということです。能登シリーズで、能登サンズ JP、CH、KR とあると思うんですけど、そこら辺を選んでおけば無難だということでございます。はい。ということで、おしまいになります。はい。ご清聴ありがとうございました。
ありがとうございます。
ありがとうございます。
興味深い話。ありがとうございます。
ありがとうございます。
と
と、
Well, it's already 3, but we can need a short break, huh? So let's take a break till 10分まで。in 7 minutes, please come. Change it.
Hi, I'm Chris, and I'm going to be talking about domains.
Well, can you hear me? Maybe you guys can hear me. So I'm sorry. Actually, I haven't finished preparing for my LT yet, so needed to change a bit time schedule of sessions. So next one will be presented by Chris. Domain specific languages. And yeah, maybe you guys can see the right domain specific language as writing your own scripting language. Okay? Yeah, I'm sorry. So after that, I will do LT. I'm so sorry. Yeah, let's get started. Yo.
Hi, I'm Chris, and I'm going to be talking about domain-specific languages, or DSLs. Games are full of systems that follow specific rules: cutscenes, combat formulas, AI behaviors, dialogue trees. And writing code for each of them can get complicated, repetitive, and difficult to tweak for game designers. So let's walk through what a DSL is, why you might want to use one, and how you can build your own lightweight DSL systems in C++. A DSL is a specialized programming language designed for a specific purpose. Or in other words, they're designed to solve problems that reside in a specific domain, hence the term domain-specific language. In contrast to DSLs, general-purpose languages, or GPLs, like C++, Python, Java, and so on, are designed to solve a wide variety of problems that aren't limited to a specific domain. Examples of DSLs include HTML used for defining web page layouts, SQL for database management, and GLSL for 3D graphics rendering and shading. Should you write a DSL? DSLs make writing complex or repetitive operations simpler, cleaner, and clearer. By working with a language that's limited to solving problems within a specific domain, those kinds of problems become easier and more straightforward to solve. This abstracts the problem and the code to solve it to a higher level, allowing you to focus on the solution without having to worry about the details. This in turn allows for faster development and readability of the code. DSLs also allow you to modify the functionality of your program without modifying the program itself, such as by reading a text file that the program can then use to dynamically construct its functionality based on the contents of the file. This makes the functionality of your game or program able to be modified by the user without requiring the program to be recompiled. There is usually less performance cost to using a DSL instead of a GPL because they are more limited. Keep in mind there are a few trade-offs to writing a DSL. DSLs can be difficult to debug since they may lack debugging tools such as breakpoints and stack traces, or language features such as data types and type safety. Because DSLs are limited in scope, they may be more difficult to use to solve a complex problem that another language may be able to handle easily. DSLs do have an upfront development cost and may have maintenance costs. They can be extended to handle a wider scope of problems, but this can sometimes be difficult to do depending on how much they need to be extended. While DSLs can be very useful to speed up and improve development, they do have a small memory and performance cost. But depending on your requirements, this is usually a small cost in comparison to using a general-purpose scripting language like Lua or Python. Suppose we need a system to calculate an arbitrary equation to solve for the damage a character does, with the end goal being that a game designer can adjust the equation easily. We might want a damage calculation such as damage equals modifier times the sum of strength and 2, but the program doesn't know what the equation is until runtime, for example because it's stored in the character's file which is loaded at runtime. This is where expressions come in handy. Expressions are objects that return a value but may be compounded with other expressions, such as math expressions like adding or multiplying. For example, a single number like 5 is a constant expression. It always returns 5. Alternatively, adding two numbers together, such as 5 and 2, takes two constant expressions as inputs and returns a single number. Since adding numbers together is an expression, you can also use it as an input to another operation, such as with a multiply expression like 3 times the sum of 5 plus 2, where the constant 3 is multiplied with the expression 5 plus 2. This chaining of expressions in an arbitrary order is called an expression tree. We can represent expressions as function objects. To write a constant expression, we write the class for an object that holds a single integer value, and when the object is called as a function, it returns that value. Similarly, a sum expression holds two constants and returns their sum, and a multiply expression holds two constants and returns their product. You may have noticed with this code that we can only add and multiply constant expressions together, and it's impossible to add or multiply other kinds of expressions. So we need to modify the sum and multiply classes to store any kind of expression instead of just constant expressions. We can solve this by using C++11's function class. The function class allows us to store functions, lambdas, and function objects in a variable. With this, we can replace the constant members in our sum and multiply classes with instances of the function class. We're going to be using the function class a lot to represent expressions, so to make things easier for us, we can alias it with a using statement. As demonstrated here, we can now write a multiply expression that multiplies a constant expression with a sum expression. While it does work, writing expressions like this is still a bit cumbersome. To make it easier, we can utilize operator overloading to write them in a more natural and mathematical way. These custom operators each take two expressions and return a new expression. The plus operator takes two expressions and returns a sum expression, while the multiply operator takes two expressions and returns a multiply expression. Now the expression tree can be written using the multiply and plus operators as well as parentheses. You may have noticed so far that our expressions can only handle integer types. To support other types, we can change our expression classes to use templates. The custom operators will also have to be updated to use templates. Once we're done adding templates, we can write expressions of float, string, or anything else. Now that we have a basic expression tree system written, we can create a textual representation of it to be stored in a text file for game designers to modify and the program to load at runtime. We can create a parsing function that reads a text file and from it construct an expression tree. As an example format for the text file, we can imagine flattening our expression tree such that the child nodes in the tree will appear in line to the right of their parent. This pushes the parent nodes to the left and any children immediately follow to the right. With this format, we can represent the nodes of our expression tree in text as star, 1.5, plus, 4, and 1, each separated by a space. This format is similar to many functional programming languages, where the function is specified first, followed by the function arguments. To parse the file, we can just write a recursive function that constructs an expression based on the first token it reads. From there, it can recursively construct additional expressions for any remaining or expected tokens. While this format makes parsing simple, it's not very intuitive to read or write, making it more difficult to use. Writing a parser to handle formats that are more common or intuitive can be more complex and difficult, but it can make reading and writing expressions easier. So far, we've looked at DSLs for handling low-level math operations, but they can also be used for more high-level operations, such as game scripting. For example, suppose we need to write a cutscene that involves a character walking into a cave. Inside, an old man greets the character and gives them a sword. We can write the script in the same way as we wrote our expression tree for the math equations, but instead of representing numbers and operators as expressions, we represent various kinds of events. Let's create a simple vector object to represent our script, which will store a list of expressions. Recall that our expression type is simply an alias to C++'s function class. This means any function we write can be stored in our script. Let's begin by writing a few simple functions to use in our script. We can write a wait function, which will simply pause the thread for some duration, a print function that outputs text character by character with a latency, and a speak function that just calls the print function with some predefined text and latency values. With these functions, we can use the bind function to construct function objects, binding the arguments we want to each of the functions and store them in the script vector. In this example, our script waits 1 second, prints Alice enters a cave with 0 latency, prints some ellipses with 500 millisecond latency between each character, waits another second, and then has Bob speak, saying, "It's too dangerous to go alone, take this." To run the script, we simply loop through the expressions in the script vector and call each of them as functions. Because the arguments to the functions are bound before the functions are called, they cannot be changed between when the script object is constructed and when the functions are executed. So if Alice's name is changed, the text will not represent the change. To fix this, we can replace the bind function with an anonymous function that will concat her name to the rest of the message only when the function is executed. It's a bit cumbersome to have to bind functions for each of our script events and manually loop through them to run them, so let's write a script class to act as a wrapper with functions that handle the binding for us. We can also utilize the Fluid API design pattern to allow us to chain our events together into a single expression. Here I've written the script class to use a queue to store the expressions, and methods to queue up wait, speak, and print events, as well as a run method to execute the script. Again, we run into the issue of Alice's name being evaluated when the script is defined rather than when it is executed. We can solve this a number of ways. If we update the print function to accept a string expression instead of just a string, we can then use a lambda as an expression that returns a character's name and pass it to the print function. We can also just use a function object. Now C++ doesn't know how to concat a string expression to a string, so to support this, we can make use of operator overloading again and store the string in a constant expression and return a sum expression so that they get concatenated when they're evaluated. If you want to support interpolated strings for multilingual purposes, you could implement a more ambitious solution such as this, which makes heavy use of variadic templates. Alternatively, if the print function is updated to handle string expressions, you can make a function object specifically for string interpolation and pass it to the print function as an expression. Supporting formatted strings may be difficult to set up, but they allow support for different languages to easily be made possible without having to alter the code for different languages. We can also support if statements by creating an expression that evaluates a Boolean expression and calls a subscript if the result of the Boolean expression is true. If we update the subscript to be an expression instead of a script object, the if expression can execute any kind of expression instead of only other scripts. The script class is kind of an expression itself, so if we just update it to be callable as a function object instead of having a run method, we can also call other script objects as void expressions. To support the AND and NOT operators seen used above, we'll need some AND and NOT expressions, similar to the sum and multiply expressions from before, but they'll operate strictly on Boolean expressions. Once we have those in place, we can then overload the NOT and AND operators to apply the expressions, just as we did before with the AND and multiply expressions and operators. Currently, calling the script is a blocking function. That means the script is unable to only partially run. When executed, it will run until all the script events have fully finished. This is fine for a console application, but it's a problem for a game that needs to be updating and rendering to the screen multiple times per second. We can address this by updating the script expression to accept the delta time, the amount of time that's passed since it was last called. This will allow the script to run only for a moment of time and be able to be paused to continue again at a later time. This means we have to update the script expressions to also accept the delta time. If any expressions have unused time left over, we can forward the unused time to the next expressions in the script. Naturally, this will add some complexity to our expressions. Before, the wait expression simply called sleep4 to pause the execution of the program. Now, the wait expression is a function object to hold how much time it needs to wait. Each time it is evaluated, it reduces the amount of time it needs to wait by the delta time and returns how much time is left to wait as a negative value. Conversely, it will return a positive value for how much time is left over. For example, if it only needs to wait 10 milliseconds, but 30 milliseconds have passed, then it should forward the spare 20 milliseconds to apply to the next expression. Let's take a look at a demonstration of a few of these concepts put together. This presentation is only a sample of what can be achieved with a simple DSL. DSLs can also be extended to support loops, variables, and data types. Further explanations and examples can be viewed on GitHub at github.com/chrisbluestone/DSL examples.
Grace。ちょっと待って。拍手が入ってないよ。So, next. Yeah, my LT. So, just wait a little. I'll get ready.
はい。
Okay. Hi everyone. Thanks for watching in. Today I'll talk about Boitable and the Unity's memory layer. Also, I'm sorry. It's first time talking in English about technologies like that. So I don't have a good English skills. So, but I'll try. First, small note first. I'm sorry. This profile slide is kind of old, so my position on the company have changed. But yeah, I'm Miyukutani. My online name is Rosen. Nice to meet you. I work as a still Unity client game engineer and use Unity for social game project, smartphone game project. Also, my favorite Pokemon is the Eevee. And if you'd like deeper details, this LT, check my Kit article. I wrote it more details. So today's content first about the Unity memory. Second, basic of memory layout. Then about the offset. Last is about table. First, okay. Let's begin with there's IView or the Unity specific memory. There are three types of memory in Unity. Managed memory, C# unmanaged memory, native memory. So managed memory is used on the C# side. This memory layer is automatically managed from memory allocation and released by the OS, Mono or IR2 CPP. C# unmanaged memory is used on the C# side. Also, this memory layer is used when using a job system or burst. It's a Unity function. Use the memory allocation and release at your own list. Native memory is used on the Unity side. C++ uses this memory layer for running in Unity. Unity engineers don't use it much. So today, this time, let's focus on managed memory. Okay. So memory type. Start by zooming out and looking at how Unity addresses and manages the memory inside RAM. There are three types of managed memory: stack, heap, and native VM. So stack is a tiny fixed size block operating system. It's set up on the piece that can't grow later, which is why the and the heap. It's a memory managed by Mono. As over this is chance during the learning over and native VM memories. So this memory is used when using a code to generate code. Yeah. Oh, can you hear me? I'm sorry. Oh, buggy. Okay, sorry. I say there are three types of managed memory stored in RAM: stack, heap, native VM memory. I just talked about this description. Stack heap. It's a small memory managed by the or else this memory is allocated during the initializing. This is over the app and can't be accessed. And the heap is memory managed by Mono and IR2 CPP. The size of this memory is changed during the running of the application. Then native VM memory. This memory is used when using code to generate code. And Unity engineers, we're actually usually not aware of it. Better now. Okay, thank you. So, second heap. It's Unity developers mainly uses their stack and heap. Stack is other variables of a value type defined from other than reference type, like struct enum types. Under addresses of objects in heap and arrays allocated by stack allocator. Yeah, you can use it to save some data in stack. Then heap. it's a managed heap. Variables are it has a variables of a reference type, array, class, delegate, object, string, etc. And box the value type objects. Also, capture the variables in anonymous functions, lambda, include lambda expressions, yeah, and the static variables. Then, yeah, let's zoom in on the stack the orange box, this one. Stack has the advantage, like access to data in memory is really fast, and also strict memory management on the OS side prevents memory fragmentation. That's really good. But disadvantages, of course, there is disadvantage. Like expectation occurs if a variable contains a value outside its type range, and also since the stack's memory is small, expectation occurs when it's used up, like that. If you before into A, into B, go for, into C, go B, then memory layout will be like that. If you other into D, define, then memory layout will be like this. Next is about heap. Heap's advantage is flexible and can be used as needed. Automatic management by GC, garbage collector, minimize memory corruption and errors. Disadvantage is since
今、
うん
配信画面が
真
真っ黒になってます。
マジ
Twitch の方に。
スイッチの方マジ
ディスコードは大丈夫。
スイッチ死んでる
あ、今生きてる。
今言ってる
うん。
OK。今大丈夫 ?OK。Yeah. Disadvantage is the GC side doesn't go so far as to tidy up the used memory. Fragmentation occurs. Access to data in memory is really slow. So, I guess you need to take care of it if you want a performance of your project if you use Unity. Okay, next, basic of memory layout. About offset. Fixed it. Sorry. I guess I will make a recorded video after this event. Then gonna upload it. I'm sorry, guys. And offset memory for the class is allocated on the heap. Variables of a reference type. I already said about it, but yeah, like this. And then offset will be like that. Where a global class variables of type and is defined under instantiated memory layout order is not considered. So, but still, for example, define Hoge class and define into A, into B, into C. Then Hoge's instance of class Hoge, so memory layout will be like that. Then, if you use inheritance surfeit, like a make child of a class A, in the case of a class C with a simple inheritance, the address of a group of functions is concluded at the compile time and link time. The memory allocation configuration of a class C instance will look like as the following, like this. Sorry, I guess I'm taking a kind of long time. I'm sorry. Then, when calling hog B implemented in class B from an object of class C, it's necessary to move this pointer to the object path of B to get the pointer for class B. To do so, this pointer is moved by referencing the offset for class B that class C has. This. Yeah, change the move it to here. It's fine. This. Next, it's a last topic about voidable. Yeah, overview. Type dependent function calls are resolved using a virtual method table. It's a short name is a voidable. This is a collection of pointers to virtual functions related to the target class. If the class has a less one virtual method, a unique voidable is created for each class, like this. Voidable example. For example, looking at the table information for class B, the function pointer of the S side was override get ID, and the function pointer get ID redefined for class B with a new stored. The function pointer get ID, which is redefined for class B with new, as stored in the table. And voidtables also have disadvantages. Both. One of them is increase instance size. Instances of the virtual function holding class have pointed to access the voidable as implicitly added to the top of the class. Because of it, the class's size will be significantly larger. And performance loss, it's also not good bad. There is a little bit performance loss because the virtual function calls are made a bit voidable. This is very small, but still the overhead can quickly add up if thousands of calls are made per frame, like while for loop inside for loop and call it really a lot. It's good also. And profiling difficulty. Even if performance is improved by the use of voidable functions, it's difficult to pinpoint the cause. It's necessary to use them with a risk in mind from the beginning. Okay, so if you want to know more details about voidable and memory layout or something, then it's they're in Japanese article and Japanese books, but still, you can use translate too, like a ChatGPT and Google Translator, Okay, so yeah, it sounds good. My I recommend yeah, of course, offshore reference, or yeah, this one, virtual new and overrides in C#. It's I guess English, so it's fine. It will be fine. Okay, thank you for watching and listening to my awful LT presentation. Think about it. Okay. よいしょ。Okay. Next. Last one is let's read. We have a pre-recorded talk by Tom H.R. Stones titled The CI/CD Adventures. Please wait while we get the video ready.
Today, our topic is
Okay. Can you guys hear it? The video's audio is okay? Okay, thank you. Okay, let's start.
Today our topic is CI/CD. So CI/CD stands for continuous integration, continuous delivery or deployment. So this is basically a build and delivery process for programs. So what do we actually do? Yeah, we take parts of something like this Lego and we assemble it according to some instructions, and we arrive at some final nice result. So, and I will be talking a little bit about CI/CD with GitLab. So GitLab, we first start with the source repository. So this is our Git repository. Then we take this, we send it to a runner, so-called runner. So this runner is basically what's doing the CI/CD pipeline. And this runner is then publishing whatever it created to some registries or like some artifact storage. There are many more options what they do. So, this is just something that runs something. So you can do everything basically. So you might ask, what is a pipeline? So a pipeline is basically just a YAML file. And this YAML file contains some scripts, just some bash scripts, just some different scripts, whatever. Just some console scripts you run, basically after one another. And the pipeline might have multiple parts that just run like this, and then they have these steps of all these singular commands. And the pipeline is basically what runs on the runner. So the runner runs the pipeline. That's basically that. So let's go to some examples, what we can do. So let's say we build a Docker app. For this we need a Docker file. So this is just an example snippet of a Docker file, a little bit truncated. We take this in our Git repository and do a Docker build on with our runner. And this then is published to the container registry. So this is just very comparable to the first image about what's CI/CD in GitLab. Sure, but there are other things we can do. So Docker was like a very, let's say, standard example, right? But we can also make a Windows install. For this I wrote a small recipe. We need a little glass of wine, so this is a some Linux and Windows stuff, because usually containers on or stuff like runners run on Linux, not on Windows. So we need some Wine. We need a Windows installer framework of your choice. One would be Inno Setup. I might use that at work, I don't know. And then we need to be like resilient against warnings, because we're running a Windows program on Linux. It works. And you must be sure that we trust the result, which I guess we do, right? We do. And yeah, with this, we have a Windows installer built in our CI/CD pipeline. We just push this to the artifact repository, for example, and then we can just download a made installer for any program we want. Though, I mean, there are other things we can do with pipelines. There might be some people, I call them linter fanatics in companies, you know, and they do like their code formatting. So, I mean, if you look at this code, you see it's the same code, right? This is just some minimal C code. And now the question is, what's correct here? I mean, obviously the first one, you know, right? The second one, who wants the second one? I don't understand. But basically you can enforce this using CI/CD. So you run a linter, and the linter is basically a format checker just in your pipeline. Just like that, you have it all. And if the pipeline fails, you just reject the change. You say, the pipeline failed, I won't merge it. And there you have it. You can also do other stuff. I mean, I don't know if you guys have like a server or something, but they're expensive to run, right? They take energy, your bill is higher if you run them all the time, because you have to pay it. And if you're on the cloud, you have to pay for usage per minute anyways. So what do we want to do? We want to turn it off sometimes, automatically. So this is a kind of a cursed application, basically, CI/CD, but of course you can just turn off a server or turn it on. Like let's say it's a development server, you turn it off on Friday night and you turn it on Monday morning. No one will notice, right? And the bill will look good for management, so that's nice, right? And yeah, I mean, I alluded to this before, but we might not just have like one thing that happens, but maybe have multiple things that happen within one pipeline. Well, let's say we first do some linting, we do some building, and then we do some testing, because we can also do testing in our pipelines. Pretty nice, actually. But I mean, if your tests work, of course. And yeah, so let's go to the last more cursed application. So let's say we want to flash a firmware, for example, onto a board like this. So this is just like some microcontroller board. And maybe we want to just take some firmware and put it on there. So what do we first have to do? We need to acknowledge that this is for testing only. Please don't do it production. And don't do it for industrial machinery, right? And what we then do is we first have to kind of build the firmware. So this we will probably do on like a strong machine, because building a firmware takes time and effort and is tedious. And then you take like a device like this, which is a Raspberry Pi, and you just connect it to our board. And then you can just use the Raspberry Pi and have like a pipeline on there that just flashes the firmware onto this board. And then you can run some automated tests, or just see if the device does what you expect it to do. Like maybe it sends out like some signal over Wi-Fi or something. And this is pretty nice, actually, if you want to develop hardware. But it's also kind of, I don't know, right? You build a firmware, like just on some computer for 1 hour. And then after that hour, like it's random timing, you go to the Raspberry Pi and say, yeah, please flash this. And it will go and flash it onto that device. I mean, it might work. Also, it might just break your door lock if you don't do it in testing, right? So please be sure to use it sparingly. So I mean, I've talked mostly about like how we build stuff, which is the integration part, and a little bit less about delivery. So let's just note about this, because your trash has to get taken from like the trash heap, aka the container registry, somehow to your server, right? And for this, we can use multiple frameworks. For example, we could use Flux. And something like Flux basically just looks at your container registry, is like, is there something new? Is there something new? Is there something new? And if you find something new, it will just say, oh, I found something new, here's the change, and change like your infrastructure in some way. So Flux is useful for Kubernetes especially. And just install the newest version of your software directly onto your systems. No additional effort needed. So yeah, this is pretty useful. And yeah, basically it searches the container registry and then airdrops you stuff on your infrastructure.
So I prepared a small demo on what we can do and how we can use stuff like this. So basically I made a small repository on GitHub. This is the QR code and I will go through it a little bit. So unfortunately, like getting a local CI/CD set up just for testing was pretty much work. So we have to do some strange things. Basically, we have to add some stuff to the hosts file. So this is using this command. We also have to configure Docker like this, and we started. And then we have to apply this Docker Compose file. And Docker Compose is basically defining like how we run something with Docker and automates it basically. So we use Docker Compose for that. Then we can use Docker PS to see like what's running. So these two containers will be running. And one is GitLab, the other one is GitLab Runner. And basically we have to wait a little bit for the GitLab container to get ready because it takes time. It's not super fast in starting up. So then we also have to set another entry in our hosts file. This it's just so the registry works correctly. Then we want to push to it. So this is the container registry I was talking about before. And we then, if we now want to log into our GitLab instance, we have to execute this command, which will look at one file. This is like an automatically generated password. We just put it in with the username root. And then username root, this password, and then we can log into this. So the next step is registering our runner to the GitLab server. So for this, we go directly in our GitLab instance here. So this is already logged in. This will be a start screen, but otherwise it's the admin panel down here. You go into runners, you say create instance, run untagged jobs is important because it's like a test setup. Then I just create the runner. Then down here we have a runner authentication token. I copy this, I go over here, and basically I bash set up GitLab runner registry and this token, and then they will connect. So now we go back to GitLab, and here we see can now look at the runners after we confirm this. It still says it's offline, but it's connected now. So then as a next step, we have to we want to run this repository on this GitLab. So for this we basically add a new project in our GitLab and then follow instructions to set it as a remote. I already set this up before, so I will just git push remote2 is the name, and for mine it will automatically create all the stuff it needs. But there's more detailed instructions in the repository if you want to follow this a bit more. So then we can now leave this admin area by just going like here, looking at like projects. We have one personal project, it's called hello, it was just for testing, and we have one pending pipeline over here. You can see it here, and this one is just waiting to be picked up, and this will probably just mean that we are currently still waiting on the runner like getting online again. So yeah, this might like take a moment because it's like the initial connection. Yeah, but after some time, the runner will pick this up and run this job. I'll leave it in the background and just talk a little bit about like the job. So in GitLab, we have this GitLab CI.yaml, which is basically our definition of what we want to run. This one is really minimalistic right now. We only have one stage, the build stage, and only one job for this stage. That's the build job. And basically it runs like a Docker build directly here, just some other debug commands. Then it connects to the Docker registry and then pushes an image to the Docker registry we have in our GitLab. So the Docker registry can be found here in deploy, the container registry, and here it is. So yeah, and basically then the stuff directly runs, and this Docker builds this Docker file here. This is also like a really minimal example already used in the slides too, and this just runs the Python app here, and it's just a hello Python app with some requirements. So it's like a really minimal setup for testing out, and it's like I think a good playing point and starting point for getting to like to get into this, and you can tinker with the stuff. So I'll just show the build process, how it then looks. Basically to reset some stuff. So I run this pipeline, and now you see this build job is pending, and the state changed to running. And now we get some log output here, and you see like what it did, and then also how it then pushes the Docker stuff, and then this becomes green, and this is also nice and becomes green over here.
So join the dark stack, mess around with the stuff, and see if you like it. I hope you have fun, and CI/CD can be run like in many contexts, and many providers do have it. We have GitLab, we have GitHub, of course, too. We have many other distributions of Git that run some CI/CD. There's some stuff that's not even necessarily Git based. There are many things basically, and you can start trying out the stuff yourself by writing just some YAML and some bash code, which is everything.
Okay, thank you, Editor Stones. I surprised her. Yeah, it's first time seeing your real avatar. But it was good, great LT video. Okay, guys. Yeah, real avatar. So, let me. Okay. そうというわけで Tech Talk Together の第2回最後までご視聴いただきありがとうございました。That's all for today. Thank you so much for joining us. 相談してくれた皆さんも本当にありがとうございます。そして聞いてくださった皆さんもお付き合いいただき感謝です。Big thanks to all for today's speakers and of course to everyone who watched. 今後もまたこんな感じでね、ゆるく楽しくちょっと技術が好きな人が、カジュアルに LT できる場所として続けたらと思っています。We'd love to keep this going as a relaxed and fun space where people who love tech can come together and speak LT. Oh, sorry. よいしょ。So, 次回は7月の27日日曜日の開催を予定しています。また次回イベントの LT スピーカーも募集中ですので、興味がある方はぜひご検討いただければと思います。 we are planning to hold the next event on Sunday, July 27th. We are also currently looking for LT speakers for the next event. So if you are interested, we'd love to have you. 最後にですね、オープニングのこのアニメーションしてるビデオっていうかムービーかなこちらですね、みやさんに素材などなどをお作りいただきました。本当にありがとうございます。めっちゃ可愛い。Last thing I needed to tell you guys, this new animated opening movie is almost made by Mia-san. Yeah, thank you for her support with this event. I'll use it forever. Yeah, props. Materials. アニメーション。ではまた次回お会いできたら嬉しいです。それではまた良い一日をお過ごしください。またね。Hope to see you again next time. Till then, have a great day. Bye.